En el que pasamos el break de ahorita.
Sí, ya lo
No.
chequé ahorita con los que estaban conectados.
Ah, ok.
Sí, porque es que yo dije yo, ¿será que mi internet es el que no sirve?
No, ahorita lo hice así para que no se nos vaya más tiempo.
Ok.
Okay, so, and remember that this is the only weekend that we'll work like this, right? And the other one will be like a little bit more relaxing because we have other things to do. Well, last hour, practically our last effort to understand this last topic. And with this topic, we may close the first part of arithmetic, okay? The first part that is arithmetic. I mean, then we will join the arithmetic with the algebra, and the last topic should be the geometry. As I told you, we have these three contents to study and analyze for this class. So what about those exercises? Do you have an idea about how can you solve it? No idea? So we will discover the solution of those, focusing the topic we want to study right now. So pay attention in what is coming, and that way I think you're gonna have the chance to solve it. Well, I'm gonna need your help here in the Jamboard to organize something here. We'll tell you how to do it or what to do. But first of all, what are the relation that makes the numbers? Okay, the relation that makes the numbers are operations, and those relations works based on results. There are some results that we get, okay, and those results depends of the mathematics rules that work behind it. I'm talking about the operations like addition, subtraction, multiplication, divisions. At the end, relates numbers based on one important rule that let us understand the numbers as they are, and not just the numbers, the operations. This is related with something we call the Peano's postulates. Peano was a mathematician who proposed why the addition works like we normally learn it, why the subtraction works like this, and honestly, the subtraction and the addition, because in mathematics, supposed to the first mathematic that exists, supposed to not work with numbers, required the use of postulates, ideas, and well, was so hard. For example, to make a simple addition like 1 plus 2, which result we know is 3, you must talk about successor numbers. And successor of successor is practically count one by one, or the correspondence we learned from the beginning, the correspondence one to one. We have to keep in mind to understand the idea of number or the concept of number, one of the four skills that we say in the morning. It's practically based on these Peano's postulates. So we will not study those Peano's postulates right now. It will be maybe in other class or in the class of didactics. Maybe we will mention some of these ones, and that way we will be clear about for where or when they are useful. Okay, so there are some operations like powers, roots, and the LCM and the GCD, the least common multiple and the greatest common divisor. Don't know if you ever hear something about least common multiplier and greatest common divisor.
Yes.
Yes, okay, but let me tell you that those exercises here, the one of the buses and the one of the goodie bags, are related with those. So we may analyze first into what consists LCM and GCD in order to keep in mind the, well, the solution of those problems we start with. Okay, so here I have the addition, and here I have some of the elements I have over here. For example, the add-in, the plus sign, the add-in, the sum, the equal sign. I'm gonna help you with one of this one. What I need that you do is that you grab it and put it in the correct position. Please do it right now, because those things are like little pictures over there, little images that will help us to understand the parts of this one. Okay, so that symbol is called add-in, or is called plus sign. Okay, so this is an add-in and this is an add-in. So finally 5 is the sum. Many of you get so good this one in the test you made yesterday in the diagnostic. Okay, wait, we are with the addition. Somebody's working with her. That's so good, but let's wait. Okay, Question to you, why we can call this one like adding and this one like adding to? Why?
Because they're the two numbers that you're going to add.
Okay, so is there a problem if I call three, I mean, if I make 3 plus 2 with the exercise? Does it make a problem for the exercise?
No.
Uh-huh. Do you know what is the name of that property? Because the answer is still been 5. That's why we can call add in the first one or add in the second one, because we may change the order. It doesn't affect. Do you know what is the name?
Commutative property?
It's the commutative property. So you should participate in the forum that you will have all this weekend until Monday to participate on it, to talk about that commutative property, show one exercise like the one I show, and participate in other classmates comment with an example like the one I show. Carmen.
Lee, excuse me. This is the way you're gonna evaluate the forum.
Yeah, some of the properties works over there. You should read these and try to participate as much quickly as you can, because there are like 23 properties that I list.
Okay, we need to give an example, right?
You need to explain the property and then and then just leave it open to the other classmates to answer one of your classmates. What you will do is read what they propose the property and show an examples. For example, here is commutative property.
Okay.
Okay.
Thank you.
Welcome. Commutative property. Into what consists? It consists to change the order of an addition. Maybe we have another operation working this way too. What will be the example? Okay, this could be the example. What will be your participation? Maybe another exercise in where you can change the order. That's commutative property. It's not complicated. The forums about that so simple, okay? But you should be in like the first one participating in that forum. Okay, here we go with the subtraction. With the subtraction, we have some other elements. What are those elements? How they are? And we have 6 minus 2 equals 4. Well, I already helped you with the equal sign. What about the other elements? Minus. The minus sign, you're right. 4 is called like difference. Now, who's the subtrahend and who's the minuend? Are you sure that's the subtrahend? So then the other one must be the minuend. Okay. Are you sure it's the minuend and that's the subtrahend?
No, minuend is the first.
Why is the first one?
6.
Yeah, why? Why is the first one, Maria Daisy?
I don't know.
Because it's a bigger number.
Traen en diferencia.
It's a bigger
Términos de
number.
la vez, ¿no?
So, my question is, do you know why it's called minuend? Because it's true. The correct order is as you have it. This is the minuend. The other one is
It's called minuend because that's the number that we're going to take away from.
exactly. And the other is called subtrahend because it's the amount of units or the quantity that you will take from the other one. Now, does commutative property works for subtraction?
No.
No. Okay, this is something you can comment in your classmates' participation too. Like this property doesn't work for, you can write it as an example. Okay, so you're right. So good that you remember as well the minuend, the subtrahend, the difference, and the elements of a subtraction. Let's go now with a multiplication. Well, this one already helped you with 2 things. The multiplication sign, which is the x, and the equal sign, which is, well, that equal. Who's the multiplicand, the multiplier, and the product? Who's who? The
The multiplier must be 7 and the multiplier.
Okay, you should move it over there. I agree with you. 21 is the product.
The
No,
first one
multiplication
is
signs already there.
multiplying.
So help me with those, multiplicand or multiplier. Who is who? The 7 or the 3?
Seven is
And that number 3 is multiplier.
Is a,
Multiplicand.
multiplicand, yeah.
Okay. And then 3, the multipliers. Why 7 is the multiplicand?
Because it's the one that you're multiplying times the other one.
Uh-huh. So what means multiplicand?
It means how many times you're going to add it to get that other number.
Okay, so essentially
You're
that,
adding the 7 3 times to get 21.
and that's why the others called multiplier, because it's the one that shows you the amount of time you repeat that addition. Yes, it's like that, and essentially this is equivalent to write or to have 7 plus 7 plus 7. Yes, and that's why they receive those names, multiplicand, multiplier. In some other books, we may see that the order of the factor never affect the results. Yes, it's true, because 3 times 7 still being 21, but it represents another situation. Be careful with that detail with the multiplication, right? What about the other basic operation? We already know, the division.
Wait, the multiplier is the second one. It's not the first one.
No, so the first one is the second one, as you can see over there.
Okay.
Yes?
dividend.
Yeah, it's because that's the problem, Ms. Marcela. We normally get confused with those, right? We normally get confused with those.
Yes.
And it is because, like the addition and multiplication, that's another property. The multiplication works as the commutative property for addition. It works for the multiplication. So be careful with that detail, right? Maria, you want to say something?
No.
Okay. So let's see, who's the divisor, who's the dividend, who's the quotient? It said like that, dividend, divisor.
Dividing is 12.
Uh-huh. And divisor?
Divide is 3 and
Divisor is 3.
quotient is 4.
And the quotient is 4. Okay, you're right. Now, it's missing one more element over there. And because this division is exact, we don't see it. But what is that element? It's an element of the division.
Remainder. Remainder.
No idea?
The reminder.
The remainder.
Remainder.
In this case, because the division is exact, we don't see the remainder, but we have the dividend, we have the divisor, sorry, and we have the quotient. It's missing the remainder, which in this case is exactly 0. Well, this is the vocabulary we may use, okay, at moment to teach those expressions, because it's too common. We say students the minuend, but they don't understand the minuend, so we must explain them what minuend means. Subtrahend, the same, and especially here. Many books, well, not many, some books have some problems. For example, I have been watching some mistakes like find the multiplication when you have to find is the product, right? Or find the subtraction when the subtraction is the operation. The correct thing to say is find the difference of those numbers. Find the addition of those numbers. This kind of instructions I normally see when I check those objectives of the planning, for example, when the correct thing to say is find the sum. Those are little details that counts and that maybe will create a little confusion in our students, if we are not clear, okay? So be careful with those details, especially with division. With division, students get confused with who is who, and then they do other operation. And instead of make 12 by 3, they make 3 by 12, which will give us like 0.25, and it's not the same. Okay. So simple elements, I think you saw something about that in the diagnostic. I saw some little details over there. Not many of you have troubles over there, so I think you're clear. But let's go and talk about those greatest common divisor and the least common multiple. The greatest common divisor, or the GCF, It's essentially a common number those numbers has. It's a little, those number have, sorry. It's a little tricky. And there are two ways to get it. One way is like look for the way to factorize the number and see if one of these factorization of the number coincides with the factorization of the other one. Well, at least one number. But normally, this topic is learned based on the Euclides algorithm. And this is something of pure mathematical knowledge, but it's so easy. Euclides was a mathematician who focused a lot into the part of geometry more than the arithmetic, but he has some approaches and important properties that we're still using for the arithmetic, okay? And if we are in the context of arithmetic, we should learn about it. For example, don't know if you can tell me what is the greatest common factor or the greatest common divisor of 28 and 32? And if you know it, if you have it, can you tell me how can you get it? Do you know it?
4.
Why is, who said that? Sorry, I couldn't see. 4, you say?
Daniela. Yeah, 4.
Daniela. Okay, how do you get the 4, Daniela?
Because it could be used with 28 to get the result of 28 and to get the result of 32.
Uh-huh. So it's like a number who divides both of them.
Yeah. Yes.
Okay. So why not 2? Because both can be divided by 2.
Because you said the greater one.
Ah, nice. Because I'm talking about the greatest. So essentially what I think you did is like factor those numbers and see what they have in common, right?
Yes.
So what is the factorization of 28?
You divide by 2 and it's 14.
Uh-huh.
You divide by 2 and it's 7.
Okay, so one factorization is like 2 times 14. Another one could be like 2 times 7, you're saying?
Yes.
Okay. Do you know what are those 2, 2, and 7?
The multiples of 28.
Oh, okay. You say multiples. Okay. What about the 32? How can we decompose the 32?
The same. You divide by 2.
2, and it is 16, right?
Then you divide by 2.
And it is
And it's 4.
2 times 8, I think. That is 16.
Yes.
And then 2 times 2 times 2 times 4. And then 2 times 2. Okay, what a good way of the thing you're saying. But you told me something at the beginning. You divide by 2, but you told me you're talking about multiples. Okay. So let's see. I think that we must be clear about this. But I like that you have the knowledge. I mean, it's not first time we see the greatest common divisor of 2 numbers. Okay, I'm agree with you. And as well, it will be 4, because if you see the numbers they have in common, okay, they have 2 times 2 in common, and 2 times 2 is 4. So we may say that greatest common factor, if we're talking about factors, is 4. Now, be careful with this idea, because this essentially breaks apart the idea of the greatest common divisor if we focus in the factors of the number. I'm not saying that is wrong, but those are not the multiples, okay? We will see what they are. Or just keep in mind that they are not multiples. Now, what is the Euclidean method? And essentially, this is hiding what we want. Essentially, what we want to know is who is the greatest divisor, the greatest number who divide both of them at the same time. And divides in an exactly way. That's what we want to explore. So what this Greek mathematician proposed? He proposed to work the division, the division of two numbers in order to see if we may find the common difference. Just that there is a tricky way to do it, and is based on the algorithm of division. Well, I'm not going to explain you the algorithm of division. I'm just going to explain you what does Euclides propose. Essentially, to get the divisor of two numbers a and b, you will get the quotient z and the remainder r. If this remainder r is different than 0, then b and r will be divided as many times as needed, because you will repeat this process until you get the greatest common factor. The greatest common factor becomes the number, the remainder you get, and it is stopped when the division gives you 0, okay? Because if it's different than 0, the algorithm continues. Do you know what algorithm means? Can somebody tell me what means algorithm? No idea? Well, an algorithm is a procedure that repeats and repeats and repeats many times. So let's see y is 4. We saw it with the way of factorize the number. Yeah, you can factorize the number. Maybe somebody can say, why you didn't write it like 4 times 7? Or why you didn't write it like 4 times 8? And that way we see the 4 in common. Okay, this is one factorization. It's true. We may have a number of factorization, an amount of factorization, and a specific amount of factorization, but there is just one that works, okay, that will help us to see the number. A little bit complicated. What happened with the greatest common divisor according with Euclides? He proposed to make this division. So we will start over there. We're going to divide our two numbers to see if there is a number who divide both at the same time. And if you remember at the beginning, I told you something about the positional system and everything. It is because we may use it over here. So if we make this division, 28 divided by, 32 divided by 28, we may focus in both of the numbers because we're working tens. So we just can multiply this by a 1. By what number should I multiply 28 in order to get closer to 32, sorry?
Just the 1.
Just by 1, right? So multiplying it by 1, I will create next result. So we're going to have 28 over there, and 32 minus 28 is 4. So here's what Euclides proposed. If you got this remainder and it's not 0, you should restart again the exercise, but focus now in next division. The division of your divisor and the remainder of the of this result of the division, okay? So then you have to divide b and r. B and r will be divided. Like if we have the division of two numbers, a and b, understand and b like the divisor, and a like the dividend. You're gonna have a quotient, but you're gonna have a remainder. We will focus a lot in the remainder because it will be 0 in a moment. And this is what the algorithm is about. Algorithm means repeat the process. So I'm gonna make another division until this stops. So let's see if with this division it stops. So 4, the box, and 28. So here we have 28 divided by 4. Of course, we may not work with the 20 because there's no way to make it with the 4. Okay, so we may work immediately with the 28 and how it will be. I mean, is there a number that multiplied by 4 gives you
7?
7. Excellent. We may stop when this remainder gave us 0. So let's see. In this case, 7 times 4 is 28, exactly 28. We got remainder 0. What does it mean? It means that this divisor that we got right now, this one, this, I say the word. This divisor that we got right now, it's our greatest common divisor. This is how the Euclidean method works, and essentially works based on that. The research or the investigation of the common divisor both number has. Okay? What happened with this remainder? What happened with this remainder? What does this remainder means? of 28 and 32? Do you remember what it means?
It's the greatest common factor, right?
Okay, right now is the greatest common factor, but thinking in this as the remainder?
Not a whole, a piece.
Is a little piece of what you complete. I mean, if you're dividing 32 in 28 parts, okay, you may get one complete, and that's why we get one in the quotient, but then there will missing 4 parts out of 28, okay? So that's why we focus over there, and we made the next division. You got it? This is how the mathematicians get the calculators too, get the greatest common factor. Some of the calculators do this procedure. What's the procedure we normally do? This one. List the, well, not multiple, the divisors of the number, and then look for the greatest one. So this could be like one good idea to do it. Any question about the greatest common divisor? No? Sure? So you have 2 ways to find it. The factor method or the Euclidean method. So we're going to explore each of these ones. Let's start with the greatest common divisor. You're welcome to join the page number 17. And here I have a little question to you. What are divisors of a number? What are divisors of a number?
The numbers that, wait. I had an idea and I forgot.
The divisors are the numbers that divide a number without leaving a
Reminder.
reminder.
Okay. So divides exactly the number. You should write it like that. You can participate over there. So then comes a little logical question. If we know that, how many divisor has a number? How many divisors does a number has? That's the question. Divisors divide a number. Excellent. Numbers that divide a number. Numbers that divide the number, Stephanie, you're right. Into equal parts. That's so good. I like this one of who you wrote into equal parts. Who wrote it? And divides a number exactly is more clear now. You're right. Oh, Marcela, that's so good, Marcela. And well, you can participate over there. Okay. So let's see. We're almost done with this. So how many divisor do you think one number has? Many, infinite, or isn't a specific amount?
Depends on the number, I guess.
Okay, but my question is, are there many, infinite, or a specific amount? One of those options.
I would say many, because the bigger the number, the greater the number of divisors.
But it will be a specific amount, right?
Yeah.
Okay. Specific amount. Exactly. I mean, what are the divisors of 12? Tell me, what are the divisors of 12?
4 and 3.
Okay.
Or 2, 2, and 3.
2, 3.
2, 3,
4.
4,
6.
6,
Mm-hmm.
12 itself.
Yes.
It's missing 1.
Yes.
1.
Number 2,
You got
3,
it.
4.
Yes. So how many divisors do I have from 12?
An eight?
1, 2, 3,
Oh, no,
4,
eight.
5, 6. Oh, yeah. So it's a specific amount. It means that it has an n. So those are divisors. Can you help me finding the greatest common divisor list the divisors we have from those numbers. What are the divisors of 12? We say 1, 2, 3, 4, 6, and 12. Oh, that's so good, Carolina. And what about the divisors of 14? Oh, 2 is one of those.
1, 2, 7,
And 7. That's it, right?
Mm-hmm.
Of the list of
And
divisors.
14.
Ah, okay. And 14, you got it. Of the list of divisors, who's the greatest?
2.
2. So this is my greatest common divisor. This is my GCF if you want to see it like factor. It's the same. So greatest common divisor is 2. Try the other one, please. And here we have 34 and 24. Oh, there you go. Oh, sorry. 34 and 24. What are the, okay, divisors 1, 2. I think in both of them we have the 2, right? Yes. If you wanted, I write that 34 for you. Okay, there you go. That's okay.
I think it's the greatest is number 2.
It's number 2 of 34 and 24.
Yes.
So what will be this greatest common factor or greatest common divisor, which is the same idea? Is it 2? Are you agree? 34 is 1, 2,
I think 17 too.
17, and 34. No more. What about the divisors of 24? 1, 2, 4, well, 3. 3 is part of the list too. The 4, the 6, well, the 8.
In there, in the bottom, we
And
have it.
also 12.
Oh, okay. Also 12. Also 12. And if you see, we have to look for the greatest one they have in common. They have in common only the number 2. Well, they have in common the 1, 2, but it's not the greatest. So I agree with you. You were saying number 2 is the greatest common divisor. So be careful. We don't talk about divisors. I mean, we don't talk about multiples in here. And if you see the divisors goes until a specific amount, so we may have 10, 20, or just 2 divisors of one number. It's not that you have infinite. So be careful with this little detail. And essentially, when you find the greatest common divisor, you look for that greatest common number. Is it clear, the greatest common divisor? Yes? So essentially, we look for the number who divides, for the greatest number who divides in an exactly way both numbers at the same time. Is that useful?
Yes.
Maybe is that useful for the goodie bags? I don't know. You will analyze that. Okay, let's go with the other kind of operation we may have, and it's the least common multiple. Question to you: what are the multiples of a number? What are multiples of a number? You can Google it, no problem. Divisor, numbers who divides exactly a number. Multiples.
It says a number that is the product of a given number and some other natural number.
So practically is the product of the number you're looking for. For example, what are the multiples of 5? Is 1 a multiple of 5? So because if it's
No.
1, no, right? What number times 5 gives you 1? There's not. So what are the multiples of 5?
5.
5,
10,
10,
15,
15,
20, 25.
20, 25, and so on. Question to you: how many multiples has a number?
Infinite.
Infinite, yeah.
Infinite. Okay. So what are the multiples? Well, numbers that result from the multiplication of my number, or products of the multiplication of my number. If you want it like that, you should write the definition. But this is a big difference. That's why I don't remember who, I think it was Miss Marcela, right? When you were telling me multiples,
Yes.
those are not multiple. I think now we are clear, right? What
Yes.
multiples are and what divisors are. That's so good. Excellent. So we may do something here. It will maybe take us a little bit of time. What about the multiples of 5? And what about the multiples of 12? Can you start list the multiple? And because there are infinite, it will be a little bit tricky. Well, a little bit time consumer to find it. Is 60? I hear 60 over there, just that I couldn't hear so good. Maria, you say it, right?
Yeah.
Yes, you find it. That's so good. Of course, we should make the list. For example, 12. 12 starts with 12. Okay, I like it. Who wrote that green line of numbers? That's so good. Oh, Eunice. That's so good, Eunice. Because here we have it. Well, I mean, this list continue, right? Then you have 65, 70, 75, 80, 85, and so on. But we should get the least. That's why here the word least is so important, because we're looking for the minimum one. And if you see here, that's 60 will be the least, will coincide. Question to you, will those numbers coincide again? Do you think those numbers will coincide again?
Yes, if we keep on going and going, yes.
Yes, they will coincide as many times this LCM repeats, because at the end it makes a pattern, okay? And we don't care about the other one. We just care about that least. So the least common multiple is 60. It's like a common product those numbers show. It's not always like the multiplication of those, right? Because sometimes they have, and this is so interesting, they have divisors in common, and these affect the result at the end. I like what you're doing here, decomposing the 14 and the 28. Yes, and well, this is another way to find it. I think the least common multiple consider just the product of both of them, right? They are products. So let's see how you decompose that one. Because 14, well, we already decomposed 14, I think so, in one exercise.
It would be 28.
It will be 28 in this one, right?
Yes.
Okay. If you want it, we can make it this way, or if you want it, we can make it making the least of the factors. Sorry, not of the factors, of the multiples. However you want to do it, because you're free to do it this way. So what way you want we make it? The other one? Okay, let's make the list. Nobody says anything. Let's make the list of the 14 multiples and the 28 multiples. So here I have 14, and here I have 28. What are the multiples they make?
14,
14, 28. Give me one more. 42, 42, 56, and so on, right? What about 28? So 28, 56. That's what I was saying. Look, they will maybe coincide in another moment, okay? But we just care about the least common number they make, okay? They can make. In this case is 28, okay? So again, one is about the common thing they have, and one is about the moment they coincide. Are you clear with greatest common divisor and least common multiple?
Yes.
Yes.
Are you sure? Okay, Vamos, pues ya vamos con lo último. So if you're clear, please list some differences between them. I gave you one right now.
The first, the greatest common factor is that like the biggest that they have in common, and the least common factor is the little one.
Okay, should write this one, Ana Maria. You're right. Other difference maybe about with what they are working with? Because you're right with what you say. One works with something that is greatest, another one works with something that is smallest or the least or the lowest. What about with the elements they work with? One's working with this of the number, the other one is working with the other thing of the number.
Well, the greatest common factor is working with factors, and the least common multiple with the multiples.
Okay, that's a good observation.
I'm trying to open the.
Oh, it doesn't work?
I don't know. I think it's my computer. It's kind of weird right now. I cannot put it in the.
There is the link, maybe. Oh, it's maybe of the internet. Maybe because of the internet, maybe.
I'm gonna try on the phone.
Okay. But you got it. It's true. One's working with divisor, the other one's working with multiples. And there is one more difference, and I say it. Both are about common things, okay? But essentially, one is related with a moment and another one is related with a characteristic, I think so. A characteristic of the number. We may focus over there, maybe. Because in the exercise you will do in the assignment, yeah, I may ask you to get the greatest common factor or the least common multiple, but of a situation like the ones we start this class, talking about the buses and talking about the goodie bags. You should analyze and tell me what those problems are about. I ask you, like, with what can you solve it? Some of you say with division. You were close. And essentially, those problems are about this: greatest common factor or greatest common divisor and least common multiple. Okay? So I think we have it. You got it over there. So let's go to the next and last page, which will be about that. Can somebody help me read those problems, next situations?
Me.
And just identify which one is working with greatest common factor or LCM. Who wants to read it?
I can help you if you want.
Oh, Stephanie, please. Okay.
Okay, Janet is packaging school supplies for her new students. She has 34 pair of scissors and 52 sets of pencils. If each pack of school supplies should have an equal amount of materials, how many packs can she make?
Okay. Who wants to help in reading the doctor problem?
Me.
Read it, please.
Ana Zelaya is that it's passing a bus. Sorry. Okay, so it says doctor recommends to drink medicine at every 8 hours and to take pill B every 12 hours. If you start with both the medicine and the pill at 8 a.m. for Saturday, September 10, when you will coincide with both medicines.
Okay, when both medicines will coincide, right? It's a very interesting problem. So you may analyze right now. And tell me then what this problem is about. Is it about the least common multiple of those hours? Is this about the greatest common divisor of those expressions that I have? I don't know. You should tell me. Analyze it. Well, the only thing that I will tell you is that one is from one and the other one is for the other topic. You should analyze who is who. Because the classwork, I mean, the assignment, the homework you will do is about that, part of the assignment. And part of the exercise of tomorrow quiz will be about these two. Identify if it's greatest common factor or least common multiple situation. What about the first one?
I think on the first one we have to find the greatest common factor
Why?
because we are gonna have to divide it into packs.
Excellent. And about the exercise at the beginning, don't know if you remember the two exercises at the beginning. We have the bosses problem and the goodie bags. The goodie bags or the bosses problem is about greatest common factor. Because it's the same situation practically. Should analyze that too, okay? And we may answer this one. So I agree with you. This one is the greatest common factor because what you want to do is divide both numbers into the same amount. That's what we want to do. That way we will know how many packs can we make with this one. 22 is the greatest common divisor. Are you sure? 22 does not divide 34. It's about greatest common factor. You're right, but is it? Let's list the divisors of 34 and the divisors of 52. There are many, right? There are like a bunch. I think so.
I think it would be 50. Sorry, it would be 2, the greatest common factor between 34 and 52.
We have 1, we have 2, we have 2. So we can make just two package. 34, 2 and 17, right? That's all. There's no other way to separate the 34 pair of scissors. And here we go with 52. 52 is divisible by 1, is divisible by 2, is not divisible
by 4.
By 4, by 5 is not, by 6, no, it's not. 7, no, you can try with your calculator, being dividing the number by this one. I think the next one will be
13.
13. And I think 26. And I think itself 52. So here is 34. Yes. Wow. Yes, you were right. I think so. The greatest common. Oh, you were trying to say 2. When you somebody write the answer here, you wrote 22. I think you tried to wrote 2. Because it's true. The greatest common factor, and it's so sad, is to. Who can tell me why this is so sad?
Because they will only have 2 packs.
2 packs, come on. If you have like 24 students or 34, come on, what will you do? Okay, but it's true, right? This is what we want to evaluate. Maybe we need another number. So it means that we can make just 2 package. Wow, not good. So what about the other one? The other one is about the least common multiple, okay? We may call it multiple better, because that way, there's why we confuse the word multiple with divisor, I think so. And what will be the least common multiple? What it will be? You have ways to do it, right? You're free to do it the way you want it. Because you have 8 hours and 12 hours. What it will be?
The littlest common in 8 and 12 is 24.
And answering the question of the problem?
It will be at 8 a.m. of September 11th.
Excellent. I mean, tomorrow, it's September 11th at 8 a.m. And next day at 8 a.m. every 24 hours. You will coincide with the 2 pills, okay? You got it. So this is what these exercises are about. It's not complicated, as you can see. 24, 36, but here we coincide. 24 hours, because the LCM is 24. Excellent. 8 a.m. September 11, 8 a.m. September 12, and so on, right? So I think you got it. Any question about the LCM and the GCF? No? First exercises, because we cannot leave it unconcluded. What will be the answer for the buses? What will be the answer for the goodie bags? Because I think right now you're clear with those situations. That's on page 14. And we conclude the class with this one. Of course, you have the assignments. You asked me to give you a chance to solve it until next Friday. Okay, you have enough time to do it. My recommendation is to work on it maybe tomorrow. Remember that tomorrow you will have a quiz. That quiz will be so simple, at most like 15 to 16 questions. You can do it like honestly, you can do it like in 40 minutes. And it gave you then the rest of time to work in the project and to work in the assignments that you will have chance until next Friday. You can organize your team to work with this one. Just don't forget to participate in the forum. Okay, the forum, it's already able. You can participate in this one today. I suggest to you to do it today because it's so simple. Okay, it's just investigate. Okay, what about the buses exercise? Is it the greatest common divisor or LCM? Oh, wow. When you say is solving those exercises very quickly, that's so good. It's about least common factor here. Least common multiple is LCM, right? And well, as you can see here, you have your notes here. You don't need like, well, if you write in the notebook, you have your note and these extra notes that will help you to study for the class. The advantage is that we will not be evaluated again with these topics. Those topics close in here. Excellent. It will be 315 minutes, I think. Is it 13 hours? 300 minutes with 15 minutes. Is it, no, 6 or 5 hours with 15 minutes maybe? Is it?
5 hours with 25 minutes.
5 hours with 25 or with 15? Because if you have 300 divided by 60 minutes, it gives you 5 hours. And are missing, well, I think it's better to do the division because that's what we are doing. It's true. You have an answer in minutes, but I'm asking you in hours. So practically you have to divide 300.
Okay, so I have 315 minutes divided by 60 is right.
Exactly.
So it will be 13 hours. That's right. No.
No, it cannot be 13 hours. Just look,
sorry,
in 10
sorry.
hours, how many minutes do you
It's
have?
that I divided by 24
Yes.
hours.
Okay, so be careful. Let's make the division here. We will see what's the answer. 315. We pick those, and we have 310. What number times 60 gives you a number very close to 300? It will be 5.
5.25.
It will give you exactly 300, right? And that's why its subtraction gave us at the end 15, which is the remainder. It means that we have 5 complete hours and
With
the rest
15 minutes.
15 minutes. You got it. Okay, the exercises of the assignment are related with this. Here, how many goodie bags can we do in that meeting? We have 32. We have 42.
No,
So
wait, I made a mistake. I wrote 42 instead of
48.
48.
Uh-huh. It's 48,
Yes,
right?
I made a mistake.
Can I help you? Can I help you with her? There he is. So let's make the list again. You have 1, 2, 4. You have what other is divisor of 48? 6, 8.
4.
24, I think so. Well, 12. 24. You have a pretty huge list over here. And I think 21 too. No, 21,
No, 21 is up.
is of the other
Yeah.
one. So the least common multiple here. This exercise is not a least common multiple, the one of the party. Because if you see you have an amount of things you want to divide into the same, and I have a little question over here. Okay. Will this be enough to invite 17 children to the party? If we can make, what is the greatest number they have in common?
4.
It's 4. We can just make 4 bags with the same amount of.
Oh wait,
You know.
no, it's 8.
Okay, it's 8 because it's the greatest.
Yes.
So we just can make 8. Like the common one. Is this enough for 17 children?
No.
I think you have to go to the supermarket again. Oh my God. Well, as you can see, those things connect with real situations. And your assignments will be related with this, okay? One assignment, it's a short investigation about the Mayan numbers, but I told you something about it, okay? You should research, Google it, no problem. And well, it's almost 4 o'clock, practically 4 o'clock. It will be it for today. I know we have been a long day, but thanks a lot for your participation, your attention, and your energy for the class, okay? I hope to see you the next Saturday, okay? So bye-bye. Make it.
Thank you.
It's not about the class. It's about the assistants. Like I logged in a little bit later right now.
Oh, okay, but I got it. Yes, because this second time I got it just like checking the Google. Don't worry.
Me too. I enter a little bit later.
Okay, Kelly, yes. Kelly, I have to add your name. You have a question, Mercedes?
Yeah. Will we have access to the Jamboard, like to review?
Any moment. Okay. Jamboard is yours.
Thank you.
Even in the test. Okay?
Thank you.
But you should practice, I think so, right? Because if you go to the test with the tools and no idea, what a problem. Let's hear Marcela's question.
No, it's not a question. It's about the assistance too. In the second time we joined, I checked a little late. Okay, thank you.
But I take it here. Don't worry.
Thank you. Thank you.
Welcome. Okay, if there's no any other question, so good luck with the assignments and good luck with the test tomorrow. And I hope to see you the next weekend.
See you on Saturday.
Bye.
See you. Bye-bye.
Bye. See you.